Hello everyone, today we're continuing our data and statistics unit with section 6, which is about creating and describing scatter plots. Before we began this unit, I sent out a survey asking you to fill out your height and hand span in centimeters, and I took some of that data and I recorded it here in this chart. And I will also mention I accidentally swapped the hand span and the height, so you'll need to draw a little arrow to let you know that those are switched. This is actually the hand span measurements, and these are the heights, and it's all in centimeters. We're going to take this data and we're going to use it to create a scatter plot, and then we're going to describe that scatter plot. So starting with the scatter plot itself, I did change the scale of the graph, and I'll zoom in here so you can see that nice and clear. We are starting at 16 and we're going up by 2, 16, 18, 20, 22, 24, 26, and then we are going to go up the side by starting at 150, going up by 10. So 150, 160, 170, 180, 190. It does go up to 200, although that is quite tall, and I don't believe any of our data points will actually get up there. And I will mention that the original scales would have been good if the average heights were quite a bit shorter, and same with the hand span if our hands were a little bit smaller. So that is not going to work out with our data, so I recommend that you change that now, otherwise your graph is going to be a little confusing. So now we're going to go ahead and we're going to create our scatter plot. So we have our hand span on the x-axis and our height on the y-axis. Now I'm going to come up here and I'm going to get my data points. The first one is at 27, 189, and I'm going to cross them off as I go so that I don't accidentally record any of them in here twice. So 27, 189, and once I get to about where that will be, I'm going to mark it by putting a point, a dot, on the graph in that place. So that is the point right here, 27 centimeters for the hand span and 189 centimeters for the height. Now I'm going to go back and I'm going to continue. So I have 19 and 159, which is going to be right about there, right here. I have 17 and 160 and 17 and 155. So at 17, right on 160 and also 155. And now I'm going to continue. I'm going to just start plotting them, and I'll speed through this part on the video, but you can go ahead and plot them on your own. Okay, now you should have all your points on your graph, and it should look something like this. So if you take a look at the graph, you should notice that our data points are kind of close together, and they, in general, seem to be going kind of in this direction, meaning the longer your hand span is, the taller you tend to be. And those are some of the pieces of information that we need to use when we are describing scatter plots. So let's go ahead and take a look on the next page at all of those pieces, how we describe scatter plots. And I do have a lot of this filled in already, so you might need to pause the video to get all of this written down. I'm going to zoom in here on the response variable and the explanatory variable. So the response variable and the explanatory variable are kind of like your independent and dependent variables. So the response variable would be like the dependent variable, and it's the focus of the survey and the study, and it's the variable you make measurements or conclusions on. So this would be, because it's also considered like the dependent variable, that's your x-axis. So in our example, that's like hand span. Then we have the explanatory variable, which is like the independent variable. And that is the factor that can influence the response variable. So for us, that's height. So it's kind of saying that your height is having an influence on the length of your hand. So when describing scatter plots, you should address 4 things. We have form, direction, strength, and outliers. And sometimes people write them in a different order where they put outliers up in between form and direction, and then they have an acronym, FODS, F-O-D-S. I choose to write them in this format because form, direction, strength, and outliers is the order of which you would be using them when you're writing your description. So the form is it linear or is it not linear? Is there a line that is kind of being formed? Not necessarily a completely straight line, but do you see a line being formed? What direction is your graph going? Is it positive? Is it going up and to the right? Or is it negative? Is it going down and to the right? Is it a strong graph? Is it strong, moderate, or weak? And this piece is really looking at how close the dots are together. The further the dots are spread out, the weaker the graph is, and the closer they are to forming a line, the stronger the graph is. And then, are there any outliers? Does any of the data seem unusually far away? So if we go back a page and we look at our graph, and we're looking at form, direction, strength, and outliers, I would say that this is a linear graph because it is headed in a line. I'm not seeing a curve in our data. It seems to be going in a general trend of this direction. And because it's also going up and to the right, this is a positive graph. And I'm going to say it's not a very strong graph because we don't see one solid line. We do see the direction that it's going, and they kind of are clustered around that line, but they're not on a one exact straight line. And I would say that it's not a super weak graph either because the weaker graphs tend to be spread out a little more. So I'm going to say this is a moderate graph. So we have a positive, linear, moderate graph. And I'm going to say that we do have an outlier here because it's a little far away from our data. Typically, if your hand span is 22 centimeters, we would expect you to probably be up here in your height. So somewhere around 180 centimeters, 170 to 180. Although the other people who have a 22 centimeter hand span were a little taller than that yet. So that's kind of what our expectation would be. This guy's a little out of place. And that could even be from an error in measurement. All right, so we also have something called correlation, and correlation goes into describing a scatter plot as well. So correlation measures the strength and direction of a linear relationship. So it takes the spread of the data and it puts a number to it. It has a value so that you have a good idea of how strong or weak it actually is. Correlation is calculated using this formula. R is equal to 1 divided by n minus 1 times the sum of xi minus the mean, so each individual x minus the mean, divided by the standard deviation of x. And then you have each y minus the average of y's, all divided by the standard deviation of y. In this class, we're not going to be using this formula at all. It's just important that you see this, that this is where correlation is coming from. What's more important is this scale here. We have -1 is less than or equal to r, which is less than or equal to 1. This is your scale. Your correlation, measured in r, is going to either be -1, +1, or something in between those two numbers. If it is a +1, it means we have a really strong straight line, and it's positive. If it's -1, we have a really strong negative line. So in other words, 1 would look something like this, where it's all these dots are forming a very straight line. It's very consistent. We know where the next data point is. It'll be up here, and it's positive. It's heading up and to the right. -1 is going to do exactly the same type of form as they're strong and together creates a line, but it's going to be going down to the right because it's negative. So it would be something like this. And we would know exactly where the next data point is going to go because it's been a very strong line. There's nothing out of place. It's creating a line. If you get 0, that's saying that there is no correlation whatsoever, and your graph might look something like this. There's no telling where your data is going to be. It's just going to be all over the place. There's no trend. Nothing seems to be related at all. So we have -1, really strong, negative straight line. 0, no pattern whatsoever. Can't tell what's going on. No trend. No relation. 1, really positive, strong line. All right. So, continuing with correlation, we have a few facts we want to look at. So, correlation, we have the correlation makes no distinction between response and explanatory variables. If you switch the two variables on the axes, the R does not change. Because R is the standardized units of the observations, R does not change if the scale of the data points is changed. In other words, addition, multiplication, subtraction, and division have no effect on correlation. Correlation does not imply causation. So what that means is just because two things have correlation doesn't mean one thing impacts the other. For example, our height and our handspan, we saw a correlation between height and handspan, meaning the taller you are, the longer your handspan. But that doesn't mean that your height determines the size of your hands. We don't have enough information to say that. We can say that they're correlated. We see a pattern, they're tied together, but we can't say that one causes the other. Like the mean and standard deviation, the correlation is not resistant. Correlation is strongly affected by outline observations. So what that means is the situation or maybe the weather or age, all of those things can have effect on correlation. For example, if you were to go to Florida and you were going to survey them on how often they go ice skating, the response is going to be a little different than if you come here to Michigan and you ask us how often we go ice skating. We have cold weather, our lakes freeze. It's pretty common to go ice skating. But if you go to Florida, they have to go to an ice arena in order to ice skate. So that's just not going to be something that's as common down there because they don't have that winter weather. So that's an outline observation that would have an effect on correlation. It doesn't mean that, again, there's no causation. So just because you're from Michigan or live in Michigan doesn't mean you ice skate. And just because you are from Florida or live in Florida doesn't mean that you don't ice skate. It just means that your survey is going to be affected because you are surveying two very different groups of people who have very different circumstances. All right, now that we have looked at the different parts of describing scatter plots, where we're looking at the form, we're looking at the strength, we're looking at the direction, we're looking at if there's any outliers, we're thinking about correlation, we're going to go ahead and do some examples. All right, we're going to start here. We have this scatter plot here, and the instructions say to describe each scatter plot and to give your best guess for the correlation. So we're just estimating. We're not having anything exact. We're not calculating it. We're just giving a good estimate based on the graph. So I'm going to zoom in on this graph here, and I'm noticing that I have, we're going size in carats on the x-axis, and we have the price on the y-axis. And as I'm looking at this data, I'm noticing that they're forming a line, and it's a pretty clear line. I can see where it's going. I'm not seeing any outliers. Everything seems to be fitting in with the trend, and it's going in a positive direction. So those are the four things that I need to include in my description. The form, it's linear. The direction, it's positive. The strength, it's pretty strong. There's a pretty strong line here, so I'm going to say it's fairly strong. And the outliers, which there's none. So now I'm going to format that into a sentence. So in my description, I'm going to say, this scatter plot shows a strong for the strength, positive for the direction, linear association between, we need to be specific here, between size and carats and price. There's one more piece, we need the outliers, and I'm just going to say that there does not appear to be any outliers. So there doesn't appear to be any outliers. And now for my estimate of R, as I'm looking at that, It's positive, so I need something between 0 and 1. And it's pretty strong. It's a pretty obvious line as we look at it. So I'm going to say that that's 0.9. And again, that's just an estimate. It seems a lot closer on a scale from 0 to 1 of being a straight line as opposed to being totally scattered data with no patterns whatsoever. All right, let's take a look at this example here. Looking at this graph here, I'm going to start with my form. I'm going to say it is pretty linear. It's not a straight, complete line, but it's going in a line direction. So it's kind of a line. We have that it's the direction, it's negative, it's going down. Strength, I'm going to say this is pretty moderate. It's not super strong, but it's also not so weak that you can't tell what's going on. And for outliers, if we go kind of down the middle, forming a line, it does kind of look that there might be a couple of outliers. And we don't need to specify which ones there are in our description. So I'll show you what to do with that. So we're going to start, there is we said moderate for our strength. Moderate, we said it was negative. We said that it was linear. So there is a moderate, negative, linear association between car weight, which was on my x-axis, and miles per gallon. And now for my outliers, I'm going to say there appears to be a couple of outliers. All right, now for the correlation. So if I look back up at this graph, we were negative, so we're somewhere between 0 and -1. We do see the trend of a line, but we don't actually see one straight line. So we can't be at -1, and it's not totally all over the place, no pattern, so that's not 0. I'd say it's probably a little better than halfway between the two. So I'm going to guess for an estimate that this is about -0.6, just a little better than half. So -0.6. All right, and let's take a look at this one now. So this is a scatter plot comparing height and weight of teenage boys. And we have the height on the x-axis and the weight on the y-axis. As I'm looking at this graph, I'm noticing that it does have the general trend as the height is increasing, the weight is increasing, but it's a little all over the place. So I'm going to say that it's a slightly moderate association because you can still see the trend. It's positive, it's going up and to the right. It is linear because you do see this line pattern as it's going all together in one direction. And then, are there any outliers? I'm going to say there don't really appear to be any outliers. So let's go ahead and write our description for this. So there is a slightly moderate, is what I called that, slightly moderate positive linear association between height and weight of teen boys. There does not appear to be any outliers. All right, and now we need to estimate our correlation here. And I said it was slightly moderate, so we're going to be somewhere around 0.5, but I don't think that is so strong to be a 0.5 quite there. I'd say it's probably closer like maybe 0.3, 0.4. That would be my guess. So let's call it 0.4 in this case. It's got the general trend of a line, but you aren't seeing a full straight line. So we're going to call that 0.4, and it is positive 0.4 because our slope was positive. All right, and this is our last one here. We have age in years, and we have testosterone levels. And if we look at this graph, I'm really not seeing much of a line. The data kind of seems all over the place. I'd say that this is pretty weak. Maybe we could call it negative, but this doesn't really even look like there's much of a line either. I mean, it's kind of going on a line. It's pretty all over the place. So I'm going to say for our description here, as far as strength goes, it's definitely weak. We could maybe call it a negative linear association. I would say it's just a weak nonlinear association. I think I'm not really seeing a line. So let's call this in our description. There is a weak, and I'm just kind of thinking about it, just looking at this graph. It's really not curved, so I'm still going to call it linear, but it's not much of a line. So there is a weak negative linear association between age and testosterone levels. And if we're looking for outliers, I don't think we mentioned that before, so let's look at this graph here again. The data is so all over the place. There might be a couple outliers, like maybe this guy is a little far out. This guy seems to be a little out of place too, but there's such a scatter here that I'm not really sure that we can say that there's an outlier. So I'm going to say there does not appear to be any outliers. There does not appear to be any outliers. For my estimate with correlation, that's a very weak scatter. We said it was negative, so we need to be on the negative side. I'm saying we got to be really close to 0 on this one, so I'm just going to call that negative 0.1, but it might even be less than that. Negative 0.1. Really close to 0. There's not much of a trend. 0 would be no trend at all. So that's pretty much where we're at. That is where we're going to stop for today. We'll pick back up with regression lines in our next section.